So, good afternoon, everyone. Well, welcome to welcome once again to our regular Sunday tonic. I call it a regular Sunday tonic because it's something that at least it's an opportunity for us to meet, share ideas, troubleshoot, brainstorm on issues surrounding this emerging technology. It's an emerging technology in our country, though it's an already emerged technology in other parts of the world, but in our country, it's just emerging. So it's we always see it as important to meet every weekend like this, discuss and brainstorm. So today, basically, as I informed us last week, is going to be a question and answer session. I was expecting a lot of people to come since we have we have a couple of people that are actually practicing. So, but since we do record the meeting, I believe anybody that has question or can always refer back to the meeting, or anybody that has an area or areas that is not clear, he can always fall back to the video to get clarification. So today I decided to use my video so that we've published a couple of videos. We've published up to 12 videos on our YouTube channel. So and there is no we don't have the picture of myself, who happens to be one of the facilitators of this meeting there. So I felt today it would be good if we have if you have my picture, you can see my video, so that people will now know that it's not actually an AI generated AI generated training or AI generated person that is answering the question. It's actually a human. It's not a robot that is actually doing the organizing or participating or doing this meeting, as the case may be. So please, being a Q&A session, I would want us to please just look at the whole system and talk and ask questions you feel where you need clarification, please. I would love you to quickly to ask, so that we can brainstorm and talk about this. We can share ideas, we can see what we can do, you understand? So please, I don't know if there's any one of you that has any question that he has actually what do I call it, he has noted within the week, because I think I shared the information from Sunday last week that today is going to be a Q&A session. So I believe we should have gathered one or two questions or one or two observations that we need clarification on. So I give you guys the floor if there's anybody.
Afternoon, all.
Afternoon, sir.
Yes, I missed a couple of sessions. The manual you shared on the group. Okay. I noticed that there was a topic that has to do with the sizing of is it the cables or sizing of I think sizing of cable, right?
Okay.
Yes. So just out of curiosity, sometimes I try to I don't know, I ask questions just for clarifications and also to help some people understand more. So sometimes my questions might be, if you look at it, some people will say silly or not silly. Well, I just try to ask so that to learn more, and also to because I understand it's not everybody that likes to ask questions, and probably there are some things we assume we know, but if you ask questions, some people will get clarification more on it.
Yeah.
So I just wanted to check. I believe there are. Right? Hello, engineer. Are you there with me?
Okay. Yes. I'm here. Actually, yeah. Your question is okay. Is that what you want to ask, or you want to? Okay, you want to ask whether there are specific cable for DC or for AC? Mm-hmm. Yeah. You see.
Yes.
what do we call them? I have I think Engineer Jerry is here and Lawrence. So I throw this question to you guys, please. They are all electrical engineers. Hello, Engineer Jerry, can you hear me?
Mm.
Oh, Engineer Lawrence, Umar, can you hear me?
Yes, engineer, I can hear you.
Okay, sir, that's lovely. Yeah, Engineer Goshi is asking whether there are. He is an engineer, but he's an engineer in another aspects. So in another field. So he is asking the electrical engineers in the house whether we have different cable for AC and another and different cables for AC and DC.
All right.
Mm.
Uh, I think I'm not sure if I can be able to specify whether uh, there are different cables meant for AC and DC. Sincerely, I can't. Uh,
Okay, okay.
yeah,
So I
maybe you that you are in the field and
yeah.
you have the reservoir of knowledge and the experience. Let me give you the benefit of doubt to take
Okay.
over the stage.
Actually, you see, the DC mostly we use multi-strand cables. You understand? You know, when we talk of multi-strand cables that have many strands, not a solid core cable. You know, there are core cables and there are multi-strand cable. You understand? AC,
Mm,
you can use a core cable for AC, but you can use core cable for AC with minimal loss. You understand? With minimal loss, because the idea of this whole cabling of a thing is they are all made from copper. They are all made from copper. So, but the fact remains, we all the major thing that we need to consider when choosing cable for whether AC or DC is losses. You know, DC suffer a lot of losses. You understand? So you see this core cable. You understand? If you use it, the AC actually, when you transmit AC from point A to point B, it suffers less loss. You understand? Compared to DC. So the solid core cable, when using the solid core cable for DC, obviously it will work. You understand? But when you have a lot of voltage drop, you have losses, you know, definitely performance will definitely be affected. You understand? So efficient. So you, at the end of the day, you may not get the result you want. But if you use a multi-strand cable, you understand, a multi-strand cable is used mostly for DC. It works well for AC. You know, it can be used for AC perfectly, no issues. You understand? Since the AC suffers less loss, so if you use a multi-strand cable, you are even going to enjoy better efficiency or better delivery of power from point A to point B. You understand? So, but if you use a core cable for DC, you definitely suffer a lot of losses. There are a lot of theoretical aspect to it. You understand? Of which this particular this thing that would not allow us to cover, but practically that is how it is. You understand? Is the solid core cable works well for AC, no doubt about it. Works very bad for DC. The flexible cable works for DC, and the flexible cable works also for AC. It gives a better performance for the AC. You understand? So I don't know if your question is clear. Is clear, engineer?
Yes, thank you for the clarification. And like I said earlier, you see, my questions has enlightened not only me, but
Yes.
I think a good number of the team.
Yes, sir.
Thank you for the clarification. But when you talked about multi-strand, it's like in a layman, a cable that has
Look,
a lot of hairs, right? Masu,
here,
like
actually,
hairs,
yes,
exactly.
yes, a lot, yes.
Okay.
Even even the yeah, any multi-strand cable that it has a lot of hairs,
Mm,
you understand, works very well.
mm,
You know,
okay.
there's a skin effect. I don't know whether there's this skin effect that has to do with resistance. It talks about a cable that has a lot of what do we call it, I'm trying to get it. Skin effect. When we talk of skin effect, skin is what covers the body, right? Skin is what covers the body.
Yes.
So skin is what covers the
Mm,
body. So if you have multiple skin, I'm just trying to correlate how it. There's what we call
mm,
skin effect in what do we call it, in resistance of
okay.
materials. You understand? I think you should read more about skin effect. Let me. I'm not. It's trying to ring a bell, but I'm not too. Let me not say what is not. I'm not hundred
Mm,
percent. I can't remember 100%, but it has to do with the more the skin you have, the better, because electrons tend to flow, is it more on the skin? Okay, I think I'm getting it now. Electrons, when electrons pass in a conductor, you understand, they tend to concentrate around the skin while they are flowing. You understand the point? So when you have a core cable, a core cable has just which is just like one cable that has just one skin, like the, you won't compare the perimeter. I don't know if you understand. You just look at. I'm trying. I don't know if you.
Surface area.
Yes, surface area. Correct. That is it. Surface area of a core cable. If you have one core cable, the surface area compared to the one that has a lot. You understand? If it has a lot, then obviously, the surface area will be more. If it has a lot of strands, more surface area. That is what it means. You understand? And these electrons tend to flow around the surface area. When you pass electron, this is not like pipe water going inside. No, electrons always come towards the surface. You understand? So that is why. If you have a cable that has a lot of strand, it performs better, whether AC or DC. But DC, it's better. DC works well with multi-strand cable.
Thank you for your explanation, engineer.
Yeah, you're welcome. Thank you. So I don't know, Mr. Jerry, do we have any question?
Yeah, I want you to throw light on the difference between the flexible that you earlier mentioned
Yes,
and the multi-strand
strand.
and core. What is the difference between the three?
If you look at a core cable, our normal cable, when you talk of a cable that is a core, single core, let me use the word single core, sorry, single core, multi-strand, and flexible. Multi-strand, uh, a flexible cable actually is a multi-strand cable, but they have tinier diameter. You understand? They have the strands have tinier diameter, which makes them to become flexible. I don't know if you understand.
Yes, I do.
Which
Yeah.
makes it to be more flexible than a core cable. When you talk of a core, a cable, single core cable is just a solid copper cable. You understand? One cable.
Mm.
When you peel the insulators, you see one. Though there are multi-strand cables that comprises of there are multi-core cables that are of thicker diameters. They are not flexible. They are flexible, but not. You understand? If so, okay. Let me. I don't. I think I'm. Let me. Let us put it this way, sir. Sorry.
Mm.
For a good understanding, you understand. The
Mm.
cable that has a tinier diameter of strands. I don't know if you understand. When you
Very, very clear.
are more flexible, you understand, because even
Mm.
the core cable is flexible, but how flexible is it? You understand the point? The level of
Yes.
flexibility is what differentiates them. Solar cables, the more flexible a cable is, the better for solar performance or DC
Mm.
performance. You understand? If it's not
Yes.
too flexible, it means you should know that the strands are fewer. You understand? So, and once the strands are fewer, you should know that, and taking into consideration this skin effect we've talked about earlier, you understand? You should know that if the strands are not many, you should know that the surface area will definitely be small. You understand? So once the surface area combined or cumulative surface area of each of those strands will definitely be small, and obviously it will affect the performance as per DC application. But when you are talking of AC application, it doesn't really matter like that. But for DC, the smaller the strands are, they are going to have better cross-sectional area, which means a better cross-sectional area means better electron flow on the surfaces, you understand, and a better performance. That is why the more in fact, this thing you are talking about, I'm coming, please. I'm going to show you a video of something
All right.
that is a picture. It actually is a flexible cable, but it was used for DC, for solar application. But do you know that this cable has strands oh, thank God. Yeah, let me share the screen. These cables are okay. Just hope. Aha. These cables are actually flexible, multi-strand. But the problem with the cable is, the strands are actually bigger. They are big. They are larger compared to the normal ones we talk about. Good. So let me share the screen so you can see. Are you seeing my screen?
Yes, yes.
Do you see what happened here? Can you see what happened here?
I can't
Hello?
see the screen.
You can't see the screen. Wow, what did happen? You can't see. Okay, let
Okay,
me see.
okay, okay, okay. I'm seeing it. I'm seeing
You
it.
can
It
see.
got burned, right?
It got
I'm
burned.
seeing it. I'm seeing
It
it.
got
Yes.
burned. You understand? So
Mm.
the contractor on this project called me. This project was actually implemented, was done in a bank in Sokoto. So the guy called me. He said he doesn't understand. Cables got burnt. You understand? I now told him that, which type of cable did you use? He said it's flexible. He sent the cable to me. When he sent the picture to me, I now saw it. This cable didn't look like the ones that has tiny strand. You understand? It looks more
Mm.
of twisted armored cable. You understand?
Remote cable.
I
Exactly.
looked, but do you know that these are actually tied as the flex? It was sold to him as a flexible cable. It was sold to him as a flexible cable. You understand? It was sold to him as a flexible cable because by touching, looking at it, it has the tiniest strand. But those
Mm.
strands are not actually very tiny. You understand? Quality of cable. This is the what wrong choice of cable can cause. You understand? So this guy thought he was using the normal conventional flexible cable we use for DC. You understand? But look at what happened at the end of the day. I told him that these cables, in fact, the insulation is even poor from day one, from what I'm looking at. You understand? So it was when I now contacted one or two people that do cable, because I have never used this type of cable. I sent it to one dealer of a cable. He said, no. These are flexible cable for sure, but the number of strands are fewer than if you have a 35 mm of an original cable with 35 of this cable, you will discover that the number of strands are fewer in this one compared to the original one. So we are talking about cross-sectional area, the skin effect that we talked about earlier. You understand? It all if you're calculating now, he may be calculating that, okay, he may be in his design. If I get a 35 cable, I do it. If it's a quality, it should be able to withstand so amount of current. But because of the quality of this cable, it couldn't withstand it. You understand? So you see, it affected his own project at the end of the day. So these are some of the things that we need to be watching out for. Thank God that this question came up from Engineer Isa. Honestly, these are some of the things, please. Cables. Our cables, the strands, if you want to buy cable, please, they shouldn't just go and give you cables, just fold them, it's flexible. No, look at the cross-sectional area, look at the strands. Does it have a lot of strands? And this, the finer the strands are, the better. You understand? Because if you have a finer, if it's finer, then obviously it has a good number of strands, and a good number of strands means you have a good cross-sectional area. Good cross-sectional area means your electron flow will be what? Smooth. Smooth electron flow means current will flow. So that is it, please. So I said I should thank God. Thank you, Engineer Isa. This your question has brought up some things that are very, very important.
Most welcome, sir.
Thank you.
Okay, so just in line with since we are talking about
Yes, sir.
cables.
Yes, sir.
Yeah, so
Earlier I was looking for you, Umar, to answer the question, but it be like say
my
yeah?
background was very, very noisy.
Oh, okay,
So
sorry, I understand.
yeah, so since we're talking about cabling,
Yeah.
there's this practice in the industry
Mm,
whereby you're looking for a particular size of a cable and
mm,
you're unable to get that cable. For instance, now you want to use a 16 cable, but
yes.
you're unable to get it. So
Mm,
at the end of the day, maybe you have a 10 mm. Let me even use 10 mm. So
okay.
now you join two, you know, join two and to connect
Okay,
or get a
paralleling to.
paralleling to exactly.
Yes, sir,
Yes.
I understand.
And then there are instances again where people can join 10 and 6, to get to that 16 mm of a cable.
Mm.
What do you think about that kind of practice, and how safe is it?
Honestly, to me, if you want to parallel cables, you understand. We are engineers. At times, we are engineers. You may be in one location. You need to implement work, and time is not on yours. You have to deliver. You want to deliver. You understand. And what you have is you have these. You have, just like you said, you rightly said. I'm looking for a 16 cable, and I cannot get it. You understand. I have to now go and look for 10 in two places. Yes, two identical cables, please. Let me be very clear here on some things. It's out of this thing I'm telling you is out of experience, you understand. DC is, especially when you're handling DC, you have to be very in fact I have had instances, you understand, where of several where this issue of cables, we are talking, when you are talking of inverter installation, we actually talk of we're actually dealing with low voltage, you understand. Low voltage to deliver high power, you should obviously know that you are dealing with high current, you understand. Current always goes higher when handling DC, especially when you are handling inverter projects that have to do with large, you have to deliver high power, you understand. So if the two cables are identical, what do I mean by identical? From the same manufacturer, I don't know if you understand my point. They should be of the same, they should have the same properties. You understand? They are from the same manufacturer, and the length, please, the length, because if one becomes longer, then obviously, electron will tend to flow in the shorter path. So you may think you are having two cables, but one is obviously being overworked. Are you with me? You
Yes,
understand?
yes.
You understand the point? So you have to make sure that those cables are two cables. Me, I'm a practical person. That is why I wouldn't tell you something that is not realistic. I have had these issues, and there are times you go to work and you want to deliver. You understand? But you cannot get what you want. They say when the desirable becomes unavailable, the available becomes what? Desirable.
The
Go back about.
desirable.
Yeah, wow. So it is. So what you have now, the available now becomes the desirable. But these are the two. These are the things that you have to watch out for. You understand? If you are terminating it on a cable lock, please, they must be on an identical cable lock. You understand? Because all these things will add up to small. You understand? You are paralleling two cables. What you want to do is you want to share the load into these two cables. Length, you should all know. Length has to do. Length is a factor of resistance. You understand? Length affects resistance. So you should know that the length of these cables must be the same. Logging, when you come to log them, number one, the cable must be identical. Number two, the length must be the same. Then the third thing that I will also add is the cable logs you're using to terminate. You know, some cable logs are not actually copper. You understand? You understand the point. Some cable logs now are not copper. You think you buy a cable log that is a copper, you go, you terminate, you are comfortable that you have a copper cable, there shouldn't be any loss or whatever. At the log, you start having issues. You understand? Especially when that cable is working at a close to its threshold. I don't know if you understand. If, let's take for example, the cable works close to its threshold or its maximum, let me use the word its maximum, you know that obviously everything along the line will have to work optimally or maximum. So please, cable locks, they must also be what? Identical. So I have no problem with that. I will not tell you that no, it's bad. Somebody will tell you it's bad. Look for it. But if you cannot get it, you understand? You have to make do, but you have to take these precautions, please. So I hope this answers your question, Haji Umar.
Yes, it has answered.
Okay, that's fine. Any other question? Q&A today.
Yes, so still in regards to cabling.
Yes, sir.
Now, in design, most of the times when you carry out your calculations, you may have a particular amperage that is almost at the boundary of a particular cable that you're supposed
Okay,
to
at the
use.
boundary of a particular cable.
Yes, almost, let's say, close to the boundary of a particular cable.
Yeah, I understand. I get you.
Yes. So, what advice will you give as regards to that? Should one just go ahead implementing that cable since it's still within the cable range, amperage range that particular cable can take, or to assume maybe there will be further expansion later on and add some kind of tolerance and then jump into
The
a
next.
higher cable? So what would be your take on that?
Yeah. My take is this. You understand? And I believe, at times, some of these things are not what you if you find yourself in this kind of scenario. Let me explain to you. Mostly if we go for load analysis, what we do is we take all the load wattage, right? We sum it. You understand? But
Yes.
that is we take all the loads. This we take all the load wattages, we sum them together. When you sum these load wattages, what happens? The next thing you should know that this load, despite the fact that this load you're taking is to enable you get inverter sizing and all those things, right? So now if you look at those load critically, not all this load can come up. It all depends on, let me explain something to you, Engineer Umar. Okay, if you're going for a load design analysis in a residential building, you understand? They said they have TV, they have bulbs, they have these, they have these. After all your calculation, you find out that you're at the boundary between one particular cable and the other, you understand? So you are now thinking, okay, Kai, if I give them this particular cable, but logically thinking, you understand, this is a residential building. These loads you carry, not all of them come up online at the same time, or let me use the word online. Not all of them come up on at the same time. You understand? At times, majority of the time, in the daytime when TV is working, lights are not working. In the night when they go to sleep, when the fans are working and lights are working, TV and other things are not working. You understand? So you have to look at the nature of the place you're working. You understand? And possibility of future expansion is you as the engineer cannot determine that. You have to discuss with the client. what is the possibility of for future expansion? At times we say future expansion. Future expansion, as an engineer, what you're supposed to be doing is you're supposed to also, whatever you're doing, implementing as an engineer, you also have to look at the economical aspect of it, you understand? Because if you design a project, if you do work and economically it doesn't make sense, that means you're spending money. When the money you're spending and the result you're spending, you're getting, they don't tally, it's an issue. So you don't assume, when you're talking of future projections, you have to discuss with the client. Okay, how do you see? Do you think of expansion in the near 1, 2, 3, 4, 5 years? You understand? If there's possibility of expansion, he will tell you. If he tells you there's a possibility of expansion, obviously that staying at the lower level of that cable will not be a good one for you. It is better to go higher. But if the person doesn't show interest of expansion, eh, is expansion, you understand? You have to look at, okay, now I'm at the borderline, but at this borderline of cable A, and between cable A and cable A being the lower one and cable B being the higher one, my load falls within cable A, but it's at the borderline between cable A and cable B. I will now say, okay, this load, now it's now time for you to rethink the load. You look at this load. Okay, this load I have here, they don't obviously come up all at the same time, you understand? So obviously you should know that whether they come up or they don't stay long, they will obviously come down, you understand? So those are little, what do I call it, those are things that you have to use your own knowledge and discretion and this thing to now look into that, you understand? But there are places, you understand, where, let's take for example, there was a project I did for an institute that have heating elements, you understand? We all know what heating elements are. They are purely resistive loads, you understand? Okay, I now said, okay, they have labs that they work. Once they come, their work there is to on these heating elements and work. So, and when I finished calculation, I discovered that the cable falls on the borderline. If this, since this is a purely resistive load that will require steady current over a long period of time, obviously I know that no, it wouldn't be advisable to be on the lower limit. It's better to go to the upper limit, because if it works, if you are close to a boundary and it works for long, you should know that definitely this cable will definitely, the temperature of this cable will rise. Within no time, you discover that within a short period of time, you discover that the cable starts getting heated up, and obviously the performance of the system will fall. So those are some of the things we have to factor in, you understand? When you have to use a lot of, that is why this particular meeting, you understand, it saves us a lot, you understand? I won't lie to you. The experience, all these questions you're asking me at times, in the whole of my this thing, I may not have come across or felt there's a need for this particular, but when we ask each other, when we answer each other, you understand, it saves us, so that tomorrow when you see such issues, you just say, we've talked about this, you remember we've talked about this thing before. Now you understand? So that is it. I don't know if it answers your question, Omar.
Yes, it does.
Okay,
It does.
thank you, Omar. So any other question, Adam?
Engineer
Okay, so
Bala,
yes sir, Jerry is talking. Yes sir.
um, sorry, I was not available in the last meeting,
Okay sir.
but I'm trying to recall. Was it one of the meeting we're discussing about 12 volt, 24 volt of
Okay,
inverter, right?
yes sir.
So what informed the decision of the choice of either 12 or 24 volt? Because there was an instance you mentioned about a client that
Mm,
you worked for.
mm.
They later invited
Someone.
someone, a
Yes,
different, yeah,
yes, yeah, yeah, yeah.
should I say engineer. He
Yes,
came and changed some of yeah, I think the inverter too, right?
yes sir.
If I'm not mistaken. So when
Yes,
when you send, the wife later called you when you send your voice, sorry, your voice, they realized that so many things were tempered with. And at the
Yes.
point, yeah, you made mention of when you call him, you were asking him about how many volt a inverter is he using. I think I'm just
Yeah.
trying to
No, no, no.
get,
I
yeah,
understand. I understand. I get your question. Your
yes,
question is basically what what makes, or what determines the choice
yes, choice,
voltage, or voltage of
yeah,
12 volts, 30, 24 or 36. Okay,
yeah.
it's
So
very clear.
sorry, I'm now more of telecommunication guy. So
Yes,
I'll be
I know.
asking some questions that seem
No,
so
no, honestly,
basic.
no, 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 no.
Yeah,
I
but please
when I
bear with me. Yeah.
No, when I answer you, you understand. I
Yes,
You
sir.
have an electrical engineering background, you understand,
Yes, sir.
and
Absolutely.
you have the background, so it will bring back. You can easily recall some things. Okay, let me explain something to you, please,
All right.
to all of us. Inverter, you understand, an inverter system. Let us all have a look at it like this. An inverter system, we say, is a DC system that converts it is a system that converts DC to AC. So if you look at it, we all know our transformer. If we remember from basic electricity or whatever, we know that a transformer, even if, in fact, not even a basic electricity, anybody that utilizes NEPA in this country should have a basic idea that there is high tension. If it comes to an area, it is stepped down to low tension. What does that is transformer. There is nobody in this country that will tell me that his transformer at a point in time didn't have problem, and he will now, basically, growing up in this country, you will understand some things about transformer. So transformer steps up, the transformer step up current from low voltage to a high voltage, you understand. From high voltage to a low voltage, or vice versa. Transformer do that, you understand. In an inverter system, you understand, energy is stored in low voltage form, you understand, 12 volts, 48, and we're talking of how do we change it to 220 volts. So you should know that basically an inverter should have a step-up transformer. You understand the point there? Good. So step-up transformer is inside. We have a step-up transformer in the inverter. So if you want to, it's not just about the voltage we are stepping up. We are stepping, when you're stepping up voltage, you also step alongside what current, you understand. Fine, let me explain something to you. If you have a 12 volt system, me, what I have discovered, and what I use very well in inverters system for myself, that I feel it has been working for me, and I believe, this is a practical class. If you're looking at a 1 kVA inverter, you understand, a 1 kVA inverter is a 1000 VA inverter, you understand, at 220 amps. You see, the maximum current you got 220 volts. The maximum current you can take from that set of inverter setting, the inverter is 5 amps. Let's say 1000 divided by 220. You understand? It's equals to what? 5 amps. So we all know how current affects the sizing of every device. You understand? We should all know how current affects the sizing of every device. At 10 amps, a device you are going to take 10 amps is not going to be of the same size with what you're going to take 5 amps. Are you with me? Obviously, the size of a 10 amps will be bigger, right? Mr. Jerry,
Yeah.
I hope I'm
Yes,
clear.
I'm with you, sir. I'm with you. I'm with you.
Even when you're talking of cables, we've already talked about cables. We said 15 mm, 10 mm takes from so as the arms increase, the diameter what increases, right? So
Increase.
obviously
Yes.
that is how it is in in a current flow. You understand? The same thing.
Mm.
Just use that. Let's use that analogy to look at how these transformers are. So if you have a 24 volt system, a 24 volt system, okay, now we're stepping a 24 volt system, a 24 volt, a 24 volt system to, obviously, if you use a 24 volt system for a 1 kVA, you understand, 24 volt system to a 1 kVA. You are trying to, what happens if you, the maximum current you can pull from a 24, let's say, let's put at it this way, 1000 VA. 1000 VA is equivalent to 800 watts. Oh, it's equivalent to 800
Yeah.
watts, right? We have a 12
Mm.
volt system. So if we want to
Mm.
get the current you are to draw from this 12 volt system, it's simply dividing the 800 by 12, right?
Mm.
So we know that we will have a reasonable, please somebody, 800 divided by 12. I want to just give us an,
Okay. 800 divided by
800 divided
12.
by 12. Yeah. So my phone is not close by. Oh, let me use Excel. Sorry, let me just share an Excel sheet with us
Okay. Okay.
so that we can be doing it.
66.7.
What?
66.7.
66.7, right? 7 amps. So for the conversion, if you're converting this, if you're converting, if you're pulling 12 volts from, if you're pulling if you're using a 12 volt system to power a 1 kVA inverter and you're utilizing it optimally or fully, you'll be able to pull 66.7 amps. Okay, fine. You understand? 66.7 amps, you know, there's a cable sizing that you should use that falls within this range. You understand? Definitely, we've talked about sizing of device affecting current affecting the sizing of device. You understand? Okay, what happens if we use a 1000, a 2 kVA? You understand? 2 kVA inverter on a 12 volts. What happens on a 12 volts system? You know, we are going to be, is going to be 1600 divided by 12, which is going to be around 132 amps. Are you with me?
Yes.
So what happens? You know,
133.
you are handling a big, you are handling a bigger current now. You understand? Sizing of the inverter will be big, sizing of cablings will be big, components in the inverter will be big. You understand? So, but
Mm.
why if we make it to be a 24 volt system, you understand? You understand? You discover that
Yes.
you are handling what? You're dividing 1600 by 24. You still come back to your 66 point what? 7, co?
Yes. Yes.
You still come back. So you see, it all affects, these things affect the component you will use. Once you stay at that lower voltage and expecting more power, you will definitely, it will affect the type of components you use, the stress on the components, because higher current means it's just like, okay, it's just like you a high pressure flowing through a channel, you know, controlling it becomes an issue. I don't know if you understand.
Mm. Mm.
So it's better as the wattage increases, it's better for the voltage to also increase. You understand?
Mm.
Because
Mm.
that way, current you're going to be handling becomes handleable or small, you understand, or reasonable, you understand, compared to the same thing compared to what you'll be handling if, because cable sizing now, the cable you're going to connect from battery to inverter is obviously going to change. You understand the point?
Mm. Mm.
What of the stress on the battery itself, pulling that kind of current from the battery? You get the point?
Yes.
So all those things, you understand? So that is why the way I do it, the way I look at it is this very simple. The higher, as you're going higher, 2 kVA, it's always advisable to go for 48 volt, 24 volt system. If it is going for 3.5, you should look at your cable. The cable you are going to be using for all those things should be something that should be able to, you shouldn't be, but because by the time you go 5 kV and you're using a 12 volt system, my brother, you use 95 cable. You understand?
Mm.
You
Mm.
use 95 cable because the current you'll be pulling at 12 volts, you understand, will be very high. So though there are inverters that do that, but me, I am not too a fan of that, because even when it comes to charge, what do we call it? If you are using solar now to power it, you understand, cables that will be flowing, we will be using from charge controller. Once the voltage is low, what you'll be handling, the amount of current you'll be handling will obviously be high for you to get the desirable desirable power output. You understand? So that is just it. So all these things. That is why you see an inverter that has a low voltage and a higher low that works on operates on a lower voltage like 12 volts and maybe has like 3 kVA or so, it will generate definitely the heat. Another thing which is important is heat, losses in the form of heat. You understand? If you're stepping voltage from a low in a transformer, let me get it clear. The transformer does a lot of work, stepping from a low voltage to a high voltage. And once it's doing a lot of work, you should know that energy will be lost in the power in the form of heat. You understand? So it affects even the efficiency. You understand? But once the
Yeah.
voltage becomes high, you understand, the stepping up will the transformer will do, it will not suffer a lot of losses. You understand? And that loss in the form, so it will definitely, if you are using a lower voltage with a higher capacity inverter, I give you the assurance that you will suffer more losses because the system will be heating up. Why? A lot of current. You remember in our elementary basic elect, I power loss P is in the form of I square R. Remember,
Yes. Yes.
I square R. So you always try as much as possible to make I lower. You understand? So that is the idea. I don't know if it answers your question.
Absolutely, it has.
Good. Thank you. Thank you, sir. So any other question? Adam, one of my team member is here. So maybe
Yeah,
he has he's an active site person. So I don't know whether you have any question, Adam.
I have that. I want
Okay.
you to explain more about this micro inverter I came across sometimes back. If you know something
Okay,
about it.
micro inverter.
Yes, sir.
Micro inverters. Micro inverters. You shared something like, let me quickly, I think we discussed this thing, but I don't think to seem to. Is it the micro inverter that we talked about, Adam? Okay. Micro inverter we talked about, you sent something. From 1 minute, still, sorry. Don't seem to see it. But what I can remember about those micro inverter, what was it, Adam? Please remind me, because I think micro inverter is an emerging technology. So I can't remember what was it. The microgrid, the microgrid we talked about. I think I was talking with someone within the week about microgrids, where I don't know whether it will answer your question, Adam. It is an emerging technology. You understand? That is, when we talk about an emerging technology, we take a technology that has not been fully adopted. You understand? It's still in the pipeline. So what it means is, it basically does is that if I have an inverter system, our grids, we have a national grid that generates power and distribute power to everywhere. You understand? Majority of the country, majority of the country gets its power from the national grid. So
National.
from the national grid. So now we're talking of micro inverter systems, like it's talking of, and I think it has to do with microgrids, a scenario whereby
Agreed.
I have a power installed. I can. Hello, sorry. So I have a I have inverter installed here. You understand? If I have an inverter installed at my place and I want a situation, the inverter installed in my place, it generates power for me. And there are times power generated by this power system is way above my needs. Is way above my needs. So the new technology of microgrids has to do with an interconnection of this solar tiny microgrids. So these grids we have, like if you have a solar inverter system installed in your house, as long as it generates power, it's a grid, but it falls within the microgrid. You understand? It falls within the microgrid category. So you are generating power, but the power is at the system falls within the microgrid. So this microgrid now, I'm generating power, solar generates power for me, and this power is in excess, you understand? Or maybe when I travel for vacation, solar will continue producing, you understand? So during that time I travel for vacation, nobody is around with the power. I could decide to sell this power. You understand? I could decide to sell this power. So there's a technology that will that once the technology comes on board, interoperability. When we talk about interoperability, when you talk about interoperability, we talk about uh, standards whereby different vendors should be able to different vendors manufacturing should manufacture in such a way that device A will be able to communicate with device B, irrespective of the vendors. Communication between these devices across vendor, that's interoperability, you understand? Just like we have you have Samsung phone, you have Apple phone, you have this phone, but once you come on the network, we use the same technology to communicate. And you understand? Just like on this class now, I'm using a Dell computer. Somebody could be using a HP. Somebody could be using his phone, iPhone. We're all there's interoperability between us. That's why we could all align to achieve a common goal. We can communicate. So the same thing applies to it's an emerging technology. You understand? It's an emerging technology whereby excess power that I don't use, I can decide to resell it to sell it, not let me know, to sell it out. You understand? But it's not easy for me to just sell it out. You understand? Selling this power, for me to sell out this power, my device needs to be to have like an adapter, or let me just use just like I just want us to have an idea of how it's going to be like. If I have an inverter here, my next door neighbor I have luminous inverter, my next door neighbor has Victron inverter, and this technology comes in play. You understand? Oh, you understand? It's very simple. There is going to be an interface whereby I can plug here and plug it to my neighbor, and once they see each other, just like your USB, if you plug your USB, your computer notices that this is a device for data storage or whatever. You understand? It goes ahead to do whatever. So once I do that, so it's an emerging technology. You understand? Once this technology comes on, becomes fully adopted, it's going to be in such a way that if I have excess power generated from my grid, microgrid, I should be able to give it out or sell it out to the next person that has deficit in his power supply, and he pays me in return. So that is the idea behind the microgrids. So I don't know if it's clear. It's still an emerging technology, but I know definitely it's something that will very much come to play. You understand? So I don't know whether it's clear, Adam. Adam, is it clear?
Yes, it's clear, sir.
Okay,
Thank you.
thank you. So I don't know if
Okay,
there's
so
anyone.
yeah, so we're now in inverter. Yeah. So
Yes.
now I know that we have different types of inverter, the transformer based and transformer less based inverters. And I know that each of them they have their pros and their cons as
Yeah.
per durability, efficiency. You know.
Mm.
So what's your take as regards to the ones that are more user friendly, more durable, and you can always recommend for clients, either due to the budget of the client or location or any factor that you can always put in mind.
Okay. Thank you for the question. You see, actually, as you said it, we have inverters that are transformer based. We have the high frequency inverters, which the ones that use the modified sine waves. Or you understand? The truth of the matter is application of inverter. You understand? If an inverter, if your inverter is to power.
Sorry, please, before you continue, and I know that
Okay.
there are some that they don't work well with some certain loads.
Okay.
Yes, just an addition. Yes, so that.
Yeah. Wow. So that's good. So uh, the what do we call them? The pure sine wave. The transformer base mostly produce a pure sine wave. You understand? So what it means is such if you're doing a load analysis and you discover that there are a lot of motors, gadgets that use electric motors. You understand? Electric motors. You should know that those type of equipments work well with pure sine wave. You understand? They work very well. Like if the person is telling you that he wants to use air conditioning systems, air conditioning systems have motors in them. You understand? So it's going to work very well with transformer based, what do we call it, transformer based inverters. If the person is going to be using resistive loads, you understand, pure resistive load like heaters, heating, all those things, the inverter now, the inverter system, solar inverter system can do everything. It can do, it powers, it was initially we had the limitation that it's not good for it to use a heating elements, whatever. No, now we have batteries that can do that. Lithium ion batteries, you understand, they have long lifespan, and they can do wonderfully well, you understand, with all kind of load, because it doesn't, charging discharging doesn't affect its lifespan or performance. It's built to work ruggedly. So it all depends on, if you're using an inverter, if you're using a load that is going to be purely resistive load, you understand, one. Secondly, those is the motors that have inductive resistance. What do we call? Is it inductive resistance? Let me use inductive loads. You understand? Those that generates back EMF. It's always good to use a transformer based inverter system. The modified sine wave, in despite the transformer based inverter is less efficient compared to the modified sine wave or the transformerless. You understand? The transformerless, it's actually efficient. Its efficiency is much more. What it means is that it wastage. In the process of converting from the low voltage to the high voltage, we talked about losses in the form of heat. That one, in the case of the transformerless inverter, those ones are reduced. So for smaller loads, you understand, for smaller loads, and for loads that are non-resistive, purely resistive loads and non-inductive loads, the transformerless inverters work pretty well. You understand? Pretty well. So that is it. And concerning quality and standards, initially when we migrated from use of transformer based electronics, before then electronic may now we heavy electronics, you understand, so they are the ones that matter. And what makes those electronics heavy is the transformer in them. We were thinking when you go to buy, you weigh it is heavy, but now we have lights, the electronics that use what do we call it, switch mode power supplies. They are light and they work well. You understand, they work excellently well. So concerning there is none, some there is, to me, depending on the load, the type of load you're going to use, the type of load you're going to use actually influences your choice of inverter technology. You understand, whether you're going to use a transformer based or a transformerless. And even the AC, we have inverter ACs. This inverter ACs use the inverter ACs use the switch mode power supply system. So such inverters, such type, and even their motors, they are made to work smart. You understand? So even the inverter ACs, they work well with the transformerless inverters. So the advantage the transformerless inverter has is it's more efficient. You understand? It doesn't waste a lot of your power in the form of heat, because it doesn't have a transformer. You understand? But the other one that has a transformer, in the process of stepping up from low voltage to the high voltage, definitely you're going to suffer losses in the form of heat. So those are the things, Uman. There are a lot, like we discussed that time with you. There are a lot of good inverters now in the market. You understand? There are a lot of good inverters, both hybrid inverters, transformerless inverter, transformer. In fact, if you see one, you feel this one is better than the other. You understand? There are a lot of good inverters in the market now because of the demand and the need. A lot of good products are coming in. So I don't know if it answers your question.
Yes, it has answered. But again,
Okay.
if you can also do us well, some of those ones that you've used, or the ones that you know that are
Mm.
good. Sharing them maybe on the platform will
Okay,
also help
go a
people
long
that
way.
are people
Yeah,
people that are coming up to
yeah.
really make some choices in an
Okay,
event where they
okay.
find themselves.
But the thing I want you guys to factor in choice of inverter is very important to me is this issue of low voltage, high power output. You need to, you understand. If you look at what you want to use that inverter for, after your load analysis, you discover that this is the load I'm going to be pulling out from this inverter. Please, the next thing that you should always watch out for, if you're going to be pulling out a lot of current from this inverter, it's always wise to go for inverter. If it's a 12 volts from 1 kVA to 1.5 kVA, you can use a 12 volt system. From 2 kVA to 3.5, you can use a 24-volt system. You understand? From 4 kVA to 5 kVA, please, 48-volt system. So, and you understand the point. 48-volt system, actually, to me, you know why I love the 48-volt system now is now the 48-volt system is trying to become a standard for high power inverters, in the sense that most of these inverters now, they discovered one of the major disadvantages of a high, if you have a high power inverter like a 10 kVA, before you discover that you have to have a lot of battery bank. You understand? Because of this issue of what we're talking about, this issue of current. You understand? They tried then to make sure that management of current you're going to be handling. So they tried as much as possible to make those inverters to be at higher voltage then. But now there's something that is playing that is I like it. You understand? You could have you could have you could have I'm coming. Let me see something. If I can see something, I will share. Are you seeing my face or the screen?
Your face.
Okay,
Yes,
good.
yes.
I want to share something with us. To share something with us so that you see what they have. Technology. People are thinking actually. People are thinking. So things are happening. I want to share. Okay, I want to share this. Uh, So now, can you see this man here? Can you see there's an inverter system? If you look at the down picture, there are can you see my screen now? What I'm sharing?
Yes.
Yes.
Okay, if you look at this inverter systems, they are 10, 10, 10, 10, 10 kVA. We actually achieved 90 kVA here. You understand? Was it 90 or 100 or something kVA? We achieved 100 and something kVA here. You understand? I cannot remember exactly. But if you observe, what they did here is, that's what I'm trying to let you understand. The issue of before, if you're going higher, that's how your battery voltage will also be going high. But now we have a 10 kVA 48 volt system, and they made it in such a way that you could actually couple inverters to form a bigger capacity. If I want 20 kVA, I could just go and buy 10 kVA. I can just go and buy 10 kVA in two places, link them up to communicate. They will be on 48 volts. You understand? So once they are communicating, you understand, the excess current that we would have been having trouble with. You understand? You remember 20 kVA now will require a lot of current. You understand? So the excess current we are going to be having trouble with handling now is shared between the two inverters, and now the output kuma are matched together for you to achieve that 20 kVA. You understand? So you see, this is what they have actually achieved. So they're trying to make sure that the fact that you're going higher doesn't mean your battery voltage needs to be very, very high, because this battery of a thing is actually making some projects to be very, very expensive. Assuming you have an office premises, you understand, that you work in the daytime. You understand, you have an office premises, you work in the daytime, and you just need the sun to be powering this thing. Even even if you pull a lot of load, I don't know if you understand my point. Even if you pull a lot of load now, you see that you use it during the daytime, which the solar will support you. So you don't need to have a big battery bank. You can just go get a small for 148-volt system and couple it to your 20 kVA, which is two inverters. You understand? You know, in the offices during the daytime, there is no much load on the battery. You understand? Majority of the load is on the sun, on the solar panel. You understand? So the battery is just like a stabilizer in such cases. While you could achieve that with two 10 kVA, you achieve your 20 kVA, you could pull your load of up to 20 kVA, you could pull your load without affecting the battery because the sun is there to support you in the daytime. At night, but you know, if it was in the olden days, you have to assemble a lot of batteries that you don't need. I don't know if you understand. You don't need those batteries because this office only works in the daytime. In the nighttime now, these batteries are wasting. So these are some of the things that I believe they looked into, and they now started this coupling of inverters together to achieve desired results. So I don't know if it's clear.
Hmm.
So any other question?
Okay,
I
so
think
okay, Engineer, you can go. Just go.
no. I say I think he has done justice to the question you've asked. Anyway, you're the one
Yes.
that asked the question, but you can go ahead, please.
Mm. Thank you. Haji Umar, your question, please.
Yes, so maybe moving to battery, just for
Yeah,
us to touch base on every part of the
system. Mm.
system exactly. Yes. So
Yes.
for batteries, I know we've actually talked about the advantage and disadvantage of using ion lithium battery and the other other type of battery. Now,
Yes, sir.
basically, I know that the acid sealed battery
Yeah.
is always easier to use and maintain. But these days, people tend to prefer going with the tubular rather than the sealed battery.
Yes, sir.
One is that I know the maintenance is also another challenge on its own. But
Yeah.
again, I realize that these batteries, there are some, despite the fact that it may have the same rating, but the
Mm.
efficiency of those batteries differs greatly.
Yeah.
You might have a battery of maybe 220 AH
Mm.
of different makes, having the
Mm.
same deep cycle rating of maybe 60%. But again,
Yeah. Yeah.
when
Depth
it
of
comes to
discharge. Yeah.
the level of discharge, when it comes
Mm.
to performance, you realize that the other one is far, 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 far way better than this
The
other one.
other. Mm.
Yes. What do you think? What's your take on that one? Two, which of those batteries, in terms of the AH,
Mm.
you always want to recommend 200, 220, 240, you know, which one do you think that is more of it works well or is always good or it doesn't fail over a short period of time?
Okay. Thank you, Omar. You see, pertaining to the question of performance, let me use the word performance of different batteries, despite the fact that they are rated the same. It's quite unfortunate. You understand? It's our country. It has to do with our country. The standards. You understand? I believe the standards are the standard is are baptized, but the standards are bastardized. Let me use the word that way, because I remember. You understand? When we started this whole inverter stuff, way then, 2008 or thereabout, I remember how these batteries were very, very. Once it's a 200 AH battery, you do your load assessment, you do your load analysis, you discover that it gives you, you understand, it gives you the exact, it gives you the exact result. The performance will tally with the result you got from your calculation. But the problem we're having now is the quality has actually been bastardized. You understand? It has been, but we, you know, our country. There's nothing we can hide. You understand? This sector is a sector that is booming because the power sector, the conventional power supply has failed. So you discover that often go, people that are in this business and want to make money, they often go and do all funny things. You understand? The truth of the matter is things are not are rated on we things are not rated correctly in Nigeria. When you see something rated this, you you go to buy something. Why is it that if you go to buy something, or you in this country, you have to do a double check? You have to, so that you are not outsmarted. You understand? So in the case of battery, how would you test it? You understand? It is written. You buy it, you agree, you believe that that is it. But unfortunately, you discover it is not so. So it's not something that is. It's not something that is. It's actually a bastardization. It's a bastardization of our standard that is causing that one. You understand? Because I know how it was then. I won't lie to you. 200 AH battery, you buy it. Because I remember there was a time in our family house in Yola, I had just one 200 AH with an inverter. Once it's night, once we go to sleep, we power it. Once we power it at night for fans. You know how hot Yola could be. I remember my father's room, my mom's room, then the guy's room, three fans and other gadgets. We sleep overnight on a 200 AH battery, you understand, with a 1 kVA inverter. But can you do that now? You can't do that. You discover that the batteries in the market cannot do that any longer. What happened? The 200 AH is the 200 AH is 200 AH. The world over, the standard has not changed, but we are the ones that have changed in terms of bastardization of our standards. You understand? So that is just the gospel truth about these things. You understand? And it's quite unfortunate unless our standard operation organizations stand up to their feet. You understand? We should we should expect even worst email complaints. We should expect we should expect we should expect worse things in the future. You understand? Our standard needs to be regulated. You understand? The things, they don't actually meet up to what they are rated. That is just the gospel truth. You understand? The 200 AH is a 200 AH if the standard is met. 200 AH in Nigeria is 200 AH in America, is 200 AH in China. Anyway, you understand. But here in Nigeria, the standard has been bastardized. That is that. And concerning choice of batteries, please, tubular batteries, I normally advise you go. Even myself, I normally advise you go to these Indian guys actually that have outlets. You understand? They will give you a warranty form. They will give you a warranty form. They will give you everything that you have to that you have to that they will give you a warranty form. They will give you warranty on their products. You understand? They'll give you a good warranty, because anybody that gives you warranty on his products is, I believe, is sure is has a level of confidence on his product. I wouldn't say 100% confidence, but he has a reasonable level of confidence on his product. So I normally advise people to go to these Indian guys. You know, they are located they are strategically in our keys, in our major cities, so you can get your batteries from them. They give you a warranty form, though they check your installation to be sure that it conforms with the standard that will not affect the battery. You know, if the battery is being undercharged, the lifespan will definitely. So they will have to inspect what you are going to, where you are going to install it, how you are going to install it, to be sure that you know what you're doing, what is coming into charges. So that is just it. But I believe it's still worth it. You understand? The Indian guys, if you need good batteries, especially the tubular batteries, you understand, it's better. Even the sealed lead acid, they have them. They will give you warranty. As long as your procedure or your installation conforms to their standard, you're good to go with them. You understand? So that is my own choice. Or that is why I normally get my uh, I advise my clients, because the tubular batteries, I hardly do them. I will advise you, go for lithium. Lithium, at least I know lithium are better. You understand? Lithium are better. They will give you a long lifespan. They will give you a long lifespan. the better performance and other things. But if you want the tubular, I prefer to you to go get them those ones yourself. You understand? Or any big company that has a warranty that will give you any company that will give you a good warranty, please go for them. You understand? And it should be clearly stated that there's a warranty on this product. This. You go with them, please. So that's for there are a lot of it's in as much as we have a lot of bad batteries, there are also a lot of good batteries, you understand, tubular and the likes. So I don't know if it answers your question, Haji Umar.
Yes, it has answered my question.
So any other question? Adam, no question.
There should be more questions, sir.
If there
I
is
think
none.
those already in the field
Hmm.
have gained experience and in the process must have encountered some challenges
Yeah.
that could give them the um, um, I mean they should have so many questions to ask based on the challenges they
Yeah,
experience.
sure.
So I don't know.
The experience. Yeah. No,
Yes.
we have. I
So
think it's only Adam that is here. That and Umar. Umar is also in the field. You understand? Umar is also and
mm,
Umar has asked a number of questions. Adam asked questions. So I believe, in the absence of more questions, I think we can call it a day. You understand? We can continue the session for the Q&A because that is, that is what actually makes brings out a lot of knowledge. Even if you're not experienced, at least when you hear people that are experienced ask questions, because as long as you have plans or intention of practicing, you will definitely get
yeah,
to that stage at a point in time where you remember what so person has asked before and how it was answered. You understand? So I believe,
yeah.
in the absence of any, we can call it a day and hope to see you guys next week.
Thank you very much.
You're
We
welcome.
want to really appreciate you for giving us this opportunity
Yes, sir.
to
You're
learn.
welcome.
Yeah,
You're welcome.
it's indeed a privilege.
Thank you very much, my brother.
Thank you,
So,
sir.
Engineer Umar,
Yeah, thank you very much.
you're welcome,
Thank
my
you
brother.
for your
You're
time.
welcome.
Thank you very much, sir.
You're welcome, Adam. Thank you. So let's we'll see you next week. Thank you, sir.
But I'm much concerned that the number of participants in today's class is
Mm,
a little bit, it has reduced significantly compared to the previous classes on Zoom. Is it that they had challenges joining the Google Meet or what?
so yeah, I will ask. I will ask on the platform, but I have discovered something about people are still finding it hard to adapt to
Yes,
digital learning,
changes.
even learning online. You understand? People find it very,
Absolutely.
people are still have the feeling that online, anything that is not physical, it's not, adopting a technology is always a problem for us. You understand? But me and you, we've already, you know how many seminars you've attended online.
Absolutely.
I'm currently running a program on data analytics online. You understand?
Yes.
I have never been to the school before. I do my courses online, do my assessment online. You understand? So the fact remains,
Yes.
all depends on how you see things. You understand? Corona, after the corona episode, pandemic whole year, many things change in the world. You understand? One of the things that that actually how will I that actually changed the way we do things is the this online stuff. Schools were still going on.
Absolutely.
So schools were still going on in developed countries online, but our own, we had to shut down schools to the. But even if something happens like that now, me and you that are already used to online stuff, you understand, we will still, in fact, not just schooling, you understand,
Mm.
technical support, remote jobs, and other things, you understand. We have to adopt to technology, you understand. We just have to adopt to
We
technology,
just have
and
to.
this technology is working. That's just the truth. It's not that if it's something that is not working, you will say, it's not working, you understand. But if a technology that is working will obviously should always should motivate us to partake in it, you understand.
It's cracky.
Thank you very much, my people. Oh no, I will discuss with I will put up some messages on the platform, you understand, because the group is very large and participation is very low. On my side, it's actually discouraging, but the fact that I know, the fact remains, if each class we have the videos I shared on YouTube for free for everybody to look. Even if I'm not alive today, even if I'm not alive tomorrow, a lot of people will learn from it, you understand. So that is it.
Absolutely.
That is the idea, you understand. The idea is, what have you done during, what will you be remembered for, you understand. What
Mm.
have you done, what have you done for humanity? You understand? It's not that we just came to the world, we just extracted from the world. What did you give back to the world? That is another thing you have to look at.
Great.
Yeah, yeah. Thank you, my brother.
Yeah. You said it all. I really appreciate
Thank
once
you,
again.
Okajeri. Thank you, Mr. Lawrence.
You're
See you guys
welcome.
next week. Yes, sir.
Yeah, thank
All
you
right. Bye
very much.
bye.
Yeah.
a tattara a ji a wuri ɗaya. Bana son gani yana yawo. Jesse, me ne kake a ƙasa?